Welcome to the DX Today podcast, where you get the facts and no hype.
Great to be here, Alex. Today, we are tackling a massive shift in the AI landscape.
We certainly are. Trillion parameter models, massive data centers, and the race for scale. But looking at this new report on small language models, or SLMs, it seems the industry is pivoting hard in the other direction.
That's exactly right. We're seeing a move from the cloud to the edge. We're talking about models typically ranging from a few million to roughly 9 billion parameters. The goal here isn't to know everything in the universe, it's to prioritize low latency, privacy, and reduced computational demands.
So instead of a massive brain in the sky, we're looking at specialized intelligence right on your smartphone or IoT sensor.
Precisely.
This report synthesizes data from over 20 authoritative sources, and the projection is clear. By 2027, these small models are expected to dominate edge AI. In fact, we're looking at 3 times more usage of SLMs than general-purpose large language models. That is a staggering statistic. How did we get from ChatGPT-style giants to these compact powerhouses? It's an interesting evolution. It traces back to the early 2010s with basic compression techniques. Around 2020, we started seeing knowledge distillation, essentially transferring knowledge from a massive teacher model to a smaller student model. That gave us things like Distilbert. But the real performance breakthrough is more recent, isn't it?
It is. The game changed around 2023 and 2024.
Microsoft's Phi series really proved that a model under 4 billion parameters could rival models twice its size if the training data was curated perfectly.
1.8B, Alibaba's Qwen 3, and Jipu's GLM4. And hardware has finally caught up to support them.
That's the key. We now have Snapdragon chips and edge devices capable of running these models on just 8 gigabytes of RAM. It's shifting the focus entirely from scale to efficiency.
Let's dig into the business side. You mentioned that statistic from Gartner, that organizations will deploy task-specific models 3 times more than general LLMs by 2027. What is driving that specifically?
It's data gravity. Currently, about 75% of enterprise data is processed at the edge, in factories, on phones, in hospitals. Moving that data to the cloud is slow, expensive, and a security risk.
And speaking of expensive, the cost difference is significant.
It's massive. One 8B instruct, the running cost is around 6 cents per million tokens. Compare that to the massive cloud models, and the ROI becomes undeniable. We are seeing SiliconFlow's benchmarks showing 13% latency reductions on edge servers. For a factory doing predictive maintenance or a field op doing real-time troubleshooting, that speed saves money.
The report highlights a few top contenders in this space, 1.AI and Qwen 3. How do they stack up?
They are leading the pack. 1.8B is the go-to for multilingual tasks and general benchmarks on mobile. Qwen 3.8B is interesting because it supports a massive context window, 131,000 tokens, which makes it excellent for embedded systems that need to remember a lot of recent data. Then you have GLM 4.9B, which excels at coding and function calling.
So it's not one size fits all. You pick the specialized model for the specific hardware.
Exactly.
I want to get technical for a moment. How do engineers actually fit these models onto a device? You mentioned distillation, but the report goes deeper into the architecture.
It does. It's a 3-pronged approach.
First, you have knowledge distillation, which we touched on, training the small model on the outputs of a big one. Second is pruning. Think of this as brain surgery. You are removing the redundant weights in the neural network that aren't contributing much to the output.
And the third?
Quantization. This is crucial for edge deployment. A standard model uses high-precision math. Quantization drops that down, often to 4-bit precision.
The report actually shrinks the file size so it can fit on an RTX 4090 GPU or even a standard laptop. The report actually outlines what this looks like in code.
Right. In practice, a developer uses a framework like Hugging Face or BentoML. They load the tokenizer, load the model with a specific flag that says use 4-bit precision, and map it to the CPU or local GPU.
That no internet part leads us to the hybrid approach mentioned in the report. It's not always all or nothing, right?
No, and frankly, hybrid is where the smart money is. You run the SLM locally for immediate low latency tasks.
So the edge handles the day-to-day, and the cloud handles the heavy lifting.
Exactly. It optimizes for cost and speed simultaneously.
However, the report is candid about the challenges. It's not all smooth sailing. What are the limitations here?
Large models are great at taking a new instruction they've never seen and figuring it out. SLMs struggle with that zero-shot capability. They need to be fine-tuned for specific tasks. And hardware is still a constraint despite the advances.
It is. Even a 7 billion parameter model strains the battery and memory of a typical IoT device. Plus, while local processing is private, hybrid deployments introduce data leak risks again.
There is also a scalability issue. If you have thousands of agents running locally, orchestrating them, managing updates and errors can be a nightmare without robust systems like Kubernetes.
Let's make this concrete with the case studies from the report. Where is this actually working today?
There are 3 great examples here. First, Tredence. They are using SLMs in factories for predictive maintenance.
And that's critical because factories often have terrible internet connectivity.
Right. The model guides the technician through repairs in real time, offline. Second, we have real-time translation on wearables, models like Phi Silica running on earbuds. Because it's local, it's zero latency, which is vital for natural conversation.
And the third case study focused on mobile AI agents, one on smartphones. Silicon Flow showed that these agents could handle multilingual tasks offline. This is huge for global IoT deployments, where data costs are high. What does that mean for the industry?
It means the definition of a data center is changing. It's no longer just a massive building in Virginia.
Your car, your phone, and your factory server become part of a distributed compute mesh. Dell is predicting this will be the dominant architecture.
And we will see hardware changes to match.
We will see model hardware co-design, neural processing units, or NPUs, built specifically to run these quantized models. The efficiency gap is going to close rapidly.
For the executives listening, what are the strategic recommendations here? If I'm a CIO, what do I do tomorrow?
First, audit your tasks. Identify high-volume, low-complexity jobs like summarization or basic routing. Those are your candidates for SLMs like Phi 3.
And regarding infrastructure?
You need to look at containerization. Kubernetes is essential for scaling these deployments.
And finally, the report emphasizes open source.
Absolutely. The proprietary models are great, but for edge deployment, open source models like Llama and Phi give you the control you need over privacy and cost. Use frameworks like BentoML to host them yourself.
It seems clear that while the last few years were about how big AI could get, the next few are about how efficient it can become.
That's the reality. LLMs aren't just mini versions of the big guys. They are a completely different class of tool for a different set of problems. The organizations that master this now, optimizing for the edge, will be the leaders in 2026.
Mike, thank you for breaking this down.
My pleasure.
And thank you for listening to the DX Today podcast. Stay efficient, and we'll catch you on the next one.